In the world of data, understanding variability is key. It's the foundation upon which we build our analysis and interpretations. It's about knowing how spread out our data points are. This spread can tell us a lot about the nature of the data we're dealing with. Are they clustered close together, or are they scattered far apart? The way data points are distributed can reveal patterns, trends, and even anomalies. This spread, this variability, helps us make sense of the data and draw meaningful conclusions. Without understanding variability, our analysis might be incomplete or misleading. Imagine you're looking at the heights of students in a classroom. This simple example can help us grasp the concept of variability in a tangible way. If all the students are roughly the same height, the data has low variability. This means there's little difference between the data points. But if there's a wide range of heights, from very short to very tall, then the variability is high. High variability indicates a greater diversity in the data points. Two important measures of variability are standard deviation and standard error. These statistical tools help us quantify the spread of our data. They sound similar, but they tell us different things about our data. Standard deviation measures the amount of variation or dispersion in a set of values. A low standard deviation means that the data points tend to be close to the mean, while a high standard deviation indicates that the data points are spread out over a wider range. On the other hand, standard error measures the accuracy with which a sample represents a population. It's crucial for making inferences about the population from which the sample was drawn. Understanding these measures allows analysts to make more informed decisions and provide more accurate insights. It helps in identifying whether the observed patterns are due to actual differences or just random variability. In summary, grasping the concept of variability and knowing how to measure it is essential for anyone working with data. It ensures that the conclusions we draw are based on solid, reliable analysis. So the next time you look at a data set, remember to consider its variability. It might just be the key to unlocking deeper insights and making better decisions. Standard deviation is a measure of how spread out the data is within a single data set. It provides insight into the variability or dispersion of the data points. Essentially, it tells us how much the individual data points differ from the mean or average of the data set. Think of it as the average distance between each data point and the mean or average of the data set. This distance helps us understand whether the data points are generally close to the mean or if they are spread out over a wider range. A high standard deviation means the data is spread out over a wide range of values. This indicates that there is a lot of variability in the dataset, and the data points are not consistently close to the mean. A low standard deviation means the data points are clustered closely around the mean. This suggests that the data points are more consistent, and there is less variability within the dataset. For example, imagine measuring the weights of apples in a basket. If we weigh each apple and calculate the standard deviation, we can understand how much the weights of the apples vary from the average weight. If the standard deviation is small, it means most of the apples are close to the average weight. This indicates that the weights of the apples are quite similar with little variation. But if the standard deviation is large, it means there's a wider range of apple weights, from very small to very large. This suggests that the weights of the apples vary significantly, with some apples being much heavier or lighter than the average. Understanding standard deviation is crucial in many fields, such as finance, research, and quality control. For instance, in finance, a high standard deviation in stock prices indicates higher volatility, meaning the stock price can change dramatically over a short period. Conversely, a low standard deviation suggests more stable stock prices. In research, standard deviation helps scientists understand the reliability of their data. A low standard deviation in experimental results suggests that the findings are consistent and reliable. In quality control, standard deviation is used to ensure products meet certain standards. A low standard deviation in product measurements indicates high consistency and quality. In summary, standard deviation is a powerful statistical tool that helps us understand the spread and variability of data. By analyzing standard deviation, we can gain valuable insights into the consistency and reliability of our data, making it an essential concept in data analysis and interpretation. While the formula for standard deviation might look intimidating, it's actually quite straightforward to calculate. Step 1. Calculate the mean or average. Add up all the values in your dataset and divide by the total number of values. Step 2. Calculate the variance. For each data point, subtract the mean and square the result. Then, calculate the average of all these squared differences. Step 3. Calculate the standard deviation. Take the square root of the variance. That's it! You've calculated the standard deviation. Luckily, many software programs and calculators can do this for you automatically. Standard deviation is a powerful tool for understanding data. It tells us how much variation there is in a dataset. This is useful in a wide range of fields, from finance to healthcare to manufacturing. For example, a financial analyst might use standard deviation to measure the volatility of a stock. A high standard deviation indicates that the stock price fluctuates widely, while a low standard deviation suggests a more stable stock. In manufacturing, standard deviation can be used to assess the consistency of a production process. A low standard deviation means that the products being manufactured are very similar, while a high standard deviation suggests more variability in the production process. Section 5. What is standard error? While standard deviation measures the spread of data within a single sample, standard error takes it a step further. It tells us how well our sample mean represents the true population mean. Think of it this way. If you take multiple samples from a population, each sample will likely have a slightly different mean. Standard error measures how much these sample means are likely to vary. A small standard error indicates that our sample mean is likely to be close to the true population mean. A large standard error suggests that our sample mean might not be as reliable an estimate. Section 6. Calculating standard error. Unveiling the precision of your sample. Calculating standard error is relatively simple. Step 1. Calculate the standard deviation. Use the steps outlined earlier to calculate the standard deviation of your sample. Step 2. Divide by the square root of the sample size. Divide the standard deviation by the square root of the number of data points in your sample. The resulting value is the standard error. It tells you how much you can expect your sample mean to vary from the true population mean. Section 7. Standard error versus standard deviation. When to use what? Both standard deviation and standard error are measures of variability, but they serve different purposes. Use standard deviation when you want to describe the spread of data within a single data set, or when you're interested in the variability of individual data points. Use standard error when you want to estimate how well your sample mean represents the true population mean, or when you're interested in the precision of your sample estimate. Choosing the right measure depends on the specific question you're trying to answer. Section 8. Real-world applications, standard error and standard deviation in action. Standard error and standard deviation are used in a wide range of fields, from medical research to political polling to market research. These statistical tools help professionals make sense of data and draw meaningful conclusions. In medical research, researchers might use standard error to determine the effectiveness of a new drug. This involves conducting experiments and collecting data from both a treatment group and a control group. By comparing the means of a treatment group and a control group, they can see if the drug had a statistically significant effect. If the standard error is small, it suggests that the sample mean is a good estimate of the population mean, giving researchers confidence in their results. In political polling, pollsters use standard error to calculate the margin of error in their polls. This margin of error indicates the range within which the true value lies, considering the sample data. This tells us how much the poll results might vary from the actual opinions of the population. A smaller margin of error means more confidence in the poll results, which is crucial for making informed decisions during elections. In market research, companies use standard deviation to understand consumer behavior. Standard deviation measures the amount of variation or dispersion in a set of values. For example, they might analyze the standard deviation of customer spending to identify different customer segments. A high standard deviation indicates a wide range of spending habits, while a low standard deviation suggests more uniform behavior. Understanding these variations helps companies tailor their marketing strategies to different segments, ensuring that they meet the needs and preferences of various customer groups. Both standard error and standard deviation are fundamental concepts in statistics taught in classrooms and used in real-world applications. They provide a way to quantify uncertainty and variability, which is essential for making data-driven decisions. Whether it's developing new medical treatments, predicting election outcomes, or understanding consumer behavior, these statistical tools are invaluable. They help professionals across various fields to interpret data accurately and make informed decisions. So the next time you see a poll result or a market analysis, remember the role of standard error and standard deviation in providing those insights. They are the unsung heroes behind the scenes, making sense of the numbers and guiding us towards better decisions. Section 9. Key takeaways. Mastering the measures of spread. Understanding standard deviation and standard error is essential for anyone working with data. These measures help us make sense of the variability in our data and draw meaningful conclusions. Remember, standard deviation measures the spread of data within a single data set. Standard error measures how well our sample mean represents the true population mean. By mastering these measures, we can unlock the insights hidden within our data and make more informed decisions.